Okay, so I think this is where we left off, that we wrote a lambda expression. That pretty much does the same thing, it's just that it's a lockless boolean and it gets to the point. So what I wanted you guys to realize is that why all these things are all unnecessary, and can replace that with something as convenient as this. See, if you compare these two method calls, both are calling collections.sort, both be two parameters. The first parameter is going to be what is going to get sorted, which is the shades list in both cases. Nothing changes there. And then you need a comparator object. Now, comparator being an interface, can't really instantiate that because there are some methods that don't have any implementation. They don't have any body. So it's your task to give a body for that. One thing you could do is you can create a new class like the ID comparator we created that implements a comparator. You could do that, and then that implements a compare method. Or you can create something called an anonymous inner class. This is the example that we have over here. This is an anonymous inner class. However, you soon realize that all these things, they're all these are not important anymore, because this is the only method. This compare is the only method that needs to be implemented in that interface. When an interface has a single method that needs to be implemented, it's called a functional interface. So what we are really comparing in this sorry about all these interruptions. Okay, so what we have here is that comparator that's interface is a special interface. It's just that it has a single method that needs to be implemented, and interfaces like these are called functional interfaces that have one single method that needs to be implemented. If there were multiple interfaces, methods that need implementation, then we couldn't write something like this, because it can mean one of many different methods that are being implemented here. But the choice over here is very straightforward. It's just going to be this compare method that needs a body. So we can write it in a concise form, because the name of the method doesn't matter anymore. Okay. Just to give you a very crude example, let's say I'm teaching this class and the class has only one student registered, which is not even possible. But I mean, if I have this scenario, do I have to call for attendance? If that student is present, I just put a check mark. But then if I have multiple students, then I have to call each and everyone to see who's present or not. So it's something like this, that if there is only one method to implement, I don't even need to give the name for that method. I don't have to write compare, because this is obvious that the method that I'm writing is the compare. I don't have to specify that I'm passing two shapes, because that's exactly what the method needs, right? I don't have to say this is shape O1, this is shape O2, because these are irrelevant. If I write the names S1 and S2, this is important because I may be calling some methods on S1 or S2 to get something done. So public, int, compare, and the data types. These are not really needed. That's why we can get rid of that. The parameters themselves, they may be necessary. For example, in here, this is necessary. And that's what we do. What do we do? This method returns something. So this is going to be what's going to get returned. It's going to return you an integer after the comparison. How do you know that it returns an integer? Because that's what the compare to method does. In a string class, the compare to method takes a string and it has another string over here on the left side. It compares those two strings and returns an integer value. It can be a -1 negative number, it can be a positive number, those sort of things. I think I gave you an example of this before, somewhere over here. See this name comparator, how do we compare two names? We write it like this, right? Compare two strings. If I had something like this, can we write this as lambda expression? We can. I mean, I gave you some homeworks, and this is really important that you try these out by yourselves. I've already set final exam questions and submitted that for review. And one of those questions will have you write a lambda expression or an anonymous inner class. I forgot which one is that. But you'd have to do a comparison based on some certain keys. There's a question, something like that. So all these homeworks will get you ready. Like, if I ask you to compare by perimeter, for example, do the same thing by perimeter. Let me just do one of these examples. How do you write that? You'd have to write collections dot sort and then pass the shapes list, obviously. And this is where we have two shapes, S1 and S2, and we are going to do a comparison. However, you'd notice that when we do this comparison, it cannot be written as a single line because there is no, like, how am I supposed to do this? S1 dot get perimeter. I can't really write. Let me bring it down into the next line. This is where I can't really write S1 dot get perimeter dot compare to. Can't do that because perimeter is a primitive value. It's a double number, right? If you look at the get perimeter call, get perimeter returns a double. There is nothing like double dot compared as a primitive type, so you can't really do that. So what we have to do instead is to write multiple instructions, and that can be written in braces. Over here we wrote a single statement, and this is where we are writing multiple statements. How do you write this? This is easy. If S1 dot get perimeter is less than S2 dot get perimeter, then S1 is smaller, right? Whichever has the smaller area should be put first. If that's what you want to do, you say return -1. Else if S1 has a bigger perimeter, you return +1. Otherwise you return 0. Okay? And the method started with a parenthesis, so you should also end with a parenthesis. Is this thing clear? Can you guys compare these two things? This is actually the answer to this homework, compared by perimeter. So in class, what I did is a simple version where you can just write it in a single statement. If this is a single statement, you don't have to use braces like this. You can just write it in one line. And you don't even have to write the return statement because it's a single statement. It understands from that. However, if it's multiple statements, you can still write it as a lambda expression. But the idea is that you have to put it in curly braces with proper return statement. Is this thing clear? All right. So yeah, that's the idea. Just call that, it gets sorted, and that's that. So similarly, if I ask you to do the comparison by name or by name first, then by the area, you should be able to do that. The last one is still a challenge, and I really want you guys to try this. Have you tried this already? No? Okay. Make sure that you try out all the homeworks because some of the questions will be related to that. If you face any problem with any of those, make sure that you bring them up in class or see me in office or send me an email, whatever you feel. We also got the classroom, you can ask questions there. So in this way we can implement all these things, and we can replace functional interfaces with lambda expressions in this format. And that's the benefit of lambda expressions, that we can write code in a concise way. It's concise, it's short, because we don't have to write the extra stuff. We don't have to write the method name. We don't have to write the return type. We don't have to give the parameters types. All these things are gone. Like if you compare it with the previous ones, see, all these things are gone. And whatever you're left with, you just write that part. So that's the real benefit of lambda expression. It just lets us write things in a much more concise way. And as a programmer, it also gives you the benefit of not remembering the names of the methods that you need to call. You just call them, knowing that it's there. Makes your life easy. What I want to show next is also some more fun stuff that will also make your life easy. And the way I think I'm going to run today's class is that I'll show you some examples and I'll give you some tasks to try right now. I want to do it in this way because, well, this week we didn't have our lab class. Next week we will have one, but I guess we won't have much after that. Because today is 16th, we'll have 3 more classes. What am I looking at? I couldn't note that. 1, 2, 3, 4, 5 classes. Counting the very last one. What's that? 29th. 29th is the last day of classes. So at most we'll have 5 classes, and we'll need the I have some stuff that I haven't covered yet. I haven't done anything with 2D drawing and animation, but there is a good library in Java that lets you do all that. I wanted to show that, and if I get time, I'll go into networking as well. So those 5 classes will need that. So yeah, but let's get started with the Streams API. That's what I wanted to show you, and it really simplifies a lot of the stuff. So let me upload this last bit of work. That's lambda expressions for you. We're going to look into something called streams. It came with functional programming in Java 8, and it's a really neat thing. Let me just give you a brief demo. I want to create a quick class called, let's say, what am I going to create? Let's say a person. So we'd have an ID, we'd have a name, and let's say we got age in, let's say, years. Okay, or make it a different type, so double age. So that's a person. We can have a constructor that takes in all these parameters, and we can have our regular getters, and also a toString, screen that. So this is pretty routine stuff. I mean, we have done this before a lot of times. And let us create a constructor over here as well. And we're going to call this constructor. So this is the entry point of the program. And now what I want to do is I want to create a list of persons. I want to call it person list. We can make it an array list if we want. Needed to import that. Now we can add a bunch of persons in there, right? So we can say something like person list dot add new person. We can put a person ID. We can put a name for that person, and we can throw in some age. Okay, so these are the list of people that we have just created, a bunch of random entries and nothing more. And we can go through all of these things and we can print them out. We know how to do that. We can simply run a for loop for person in person list. We just go system.out.println, print that person data, and the output would look something like this, that you get to see all these things as they will appear. Now with Java String API, you can actually take a list or any collection for that matter as a flow of data and can perform some operations on them in a very nice way. Nice, by nice I mean it's going to be fast, that's one thing. It's also going to be short to write code, and it's going to be self-explanatory in a lot of ways. So one really common task to do with the list is that you want to go through all of them to print it out. Right? That's a very common task. So how do we call that? We can write a enhanced for loop like this, which is slightly better than a for loop with indices, because we're going through each and every entry. We're not missing anything, so we start right at the beginning and we stop right at the end. So previously, before Java 1.5 came out, we'd have to write something like this: for int I equal to 0, I less than person.size, I plus plus, and then you'd see something like system.out.println person list dot get I. This has to change. This is going to be person list of size. So if you compare these two methods, I'm not saying that anything is wrong with the first one. They do the same thing. They do exactly the same thing. No problem at all. It's just that the second version is easier to read. Right? So that's a benefit. You have to write less, and it means more. You don't have to work with indices. You don't have to manipulate them, because you're going through each and every entry anyways. From here, we came to this point in Java 1.5, and Java 1.8 or Java 8 really simplified matters even more. See, we're working with the person list, and we want to treat this as a stream, as a flow of data. We can work on any collection. It doesn't have to be an array list. It can be anything really. You can treat it as a stream, and then you can say, for each item in that stream, see, there is a method called for each. What do I want to do? This is where you can throw in a lambda expression. For each person is the parameter. What do? We do system.out.println that person. So that's a use of lambda expression. What you needed to do in 2 lines can be done in a little bit simpler way. You can just write one line. You're going to treat this as a flow of data, and in the flow of data, for each of these items, what are these items? Each item in that list is a person. For each person, what are we going to do? We're going to print that person. So all these 3 examples, they do exactly the same thing. So you can see repetitions 3 times. This is the third one, this is the second one, and this is the first one. So we can print the same thing in 3 different ways. And the last one up here is a little bit simpler, or in some cases, like if you're starting with Streams API, it might be a little bit complex. However, this is actually better to write it in this way because it gives you parallel executions for free, because there with this Streams API you can write it like this, but you can also just change this thing to parallel stream and it works in parallel. So let me comment out this whole thing for now and run this thing. Did it keep the order that I put in the list? Are they getting printed in the same order? No. You see, the thing is, in our modern day CPUs, there are a lot of processor cores. Right? We hear about 4-core computers or 8-core computers. We even have octa-core phones. So not just our computers, our phones even have multiple cores. What's the use of multiple cores? Is that you can have multiple tasks running on them at the same time, and they can run fast. If you have a single core, then that would have to share the resources in all the things that run on your computer or on your phone. So it's going to get a little bit slow. With parallel computing, we can ensure that the task gets divided into multiple cores and they get executed at the same time. So what's really happening over here, we're going to print each and every record, right? And if it doesn't matter, the order of printing, if that order doesn't matter, we can say that we want to print them in whatever way. We just want to print them out, all of them. So we can divide the task. Like right now, we don't have that many. We have only 6 entries. But imagine that we have 6 million people kept in an array list and we want to print them out. It's going to take time because, well, it has to wait for the first entry to get done, then the second entry gets done, and so forth. But if you divide up the task into, let's say, 6 different cores, then one core only has to print only 1 million element compared to 6 million element. Okay, so that's the advantage of dividing the task. Printing is a bad example because it has to go through your video frame buffer, and that can really happen parallelly from multiple cores. So there is a problem with that, but that's a different story. But if I give you another example that I want to find out the average age of 6 million people, then the way you're going to compute that is going to take time. You have to run through all these 6 million data, add all the ages, and then you have to divide by the number of people, which is 6 million, to get the average age of all these people, right? However, with parallel computing, I can divide the task into different people. For example, if I have a lot of students in my class and I ask you guys to compute the average age, if I give only one student the task, go and ask every one of you guys, what's your age? Collect all the data, sum them up, divide that. If I give you that task, it's going to take time compared to another way. If I divide the task into rows, and I find representative of each row to get the job done for that row, then I can get that result quicker. Okay. So that's basically the idea. That we can have parallel stream, and that's the issue with efficiency. That this is given for free. You don't have to change any of that. If you write it as a stream, you can just change it to parallel stream. I'm not saying that you're going to do it in each and every place. It's not a good way to do it. But you have to look into your program to see what part of the program has that opportunity to be divided into multiple chunks to get stuff done faster. If you can identify those parts, then you can turn it into a parallel stream. That's for free. That's one of the benefits. And the other benefit is that you can write code in a slightly shorter way. Is this thing clear? We have used a lambda expression to print out all these people. One other thing is that since you're calling a method on each and every person, Java 8 has another nice little feature. You can actually write person list.stream for each, and here instead of writing person arrow system.out.println, you can actually write system.out 2 colons println. This pretty much means that for each and every person that's coming out of person list, call this method, pass that object to println method. That's actually a method handle. You can pass that and it gets executed. Why do we write it like this? System.out, that's the class would come from here, and in that class there is a method called println. So if you run this, see, you can still print all of that. So let me show you some more examples of this. If I declare a method public void increase age for no good reason, just for demonstrating what it is really. What we are going to do here is that we are going to increase the age by 1 year. Say whoever is 10 years old right now, if I call this increase age, his or her age is going to be 11. It's as simple as that. So if I want to call this method through lambda expression, what I would write is person arrow person dot increase age. That's going to increase the age of that person. So have a quick look at this, that the last person's age is 67, and after increase age it should be 68. If you run this example, see, that's what happens, and it's working, right? No problem with that. So we are calling this method in this way with for each. What you could also do, you could use a method handle like this. So still does the same thing. So the syntax of using a method handle is that you write the name of the class for 2 colons and then the method name without any parameters, without those brackets. Okay. These are all an effort to make you write less code. Java is notorious compared to other programming languages that to write even a simple program you have to write a whole lot of things. You have to create a class, you have to write public, static, whatever you have for in front of every method. So you have to write a lot more code compared to something like Python. So it's very verbose, and people don't like Java for that. There are many people who say that for Java you'd have to write a whole lot. So with lambda expressions and strings API, turns out that Java is a lot variable now, that you can do a whole lot of things really fast without writing a whole lot, writing these things. So previously, if you wanted to do that to increase age, the way we have learned this, I'm not saying that this is difficult, it's just that compare this with something like for person in person list, you'd have to say person dot increase age. Okay? So 2 lines of code that reads like this can be replaced with this one. And once you get a hang of it, this will really be easy to handle. Okay.
So do you get parameter to
You'd have to pass the parameter. I don't even know if that would work. Let me see. So yeah, it has to be parameterless because that's only going to pass the object as parameter. So those methods that don't take any extra parameters, only those you can call, not these ones. Okay. So we can increase the age and then we can print them. I mean, this is how you do it if you didn't know Streams API. And now if you have some idea about Streams API, you can do it in a slightly better way. That's one example, all right? Let us make it a little bit more complicated to say that I want to filter this out. I don't want to print it for each and every person. Let's say I want to print only the entries for people who are more than 50 years old, which means these two things, this person ID 7 and person ID 3, right? How do you write that? You guys should be able to do that. Let's say that's the task. With the knowledge that you have already, you could write something like this: for person in person list, if person dot get age is greater than 50, only then see some output as well. So with enhanced for loop, you could write something like this, and it would really work. Like see, printing persons greater than 50 years old with enhanced for loop. This is how it goes. It only prints 2 entries, and that's what it should do. Let me put a line gap. Yeah, so that it's better. Now I want to do the same thing. It's just that I want to do it in a slightly concise way, in a shorter way, and see how that can be done with Streams API and maybe with some Lambda expressions. So let me copy this. With Streams and Lambda, I want to try the same thing. So how do we do this? First of all, persons list dot string, turn it into a string. And then, actually this is person list, not persons list. Dot string dot, first of all, I want to filter things out. I don't want to take all these things. I want to filter them out. And filter actually takes a interface in here, which is called a predicate. That means that you can put in a Lambda expression to replace that. Because that's what we've been doing. Which persons do we want in here? Only the persons that are more than 50 years old. So we can say this predicate has to return a boolean. So person arrow person dot get age greater than 50. If that's true, only those persons you're going to take, otherwise you don't. What you get out of it once you do that is a subset or sublist of the original list. once we do the filter. So what we do then, we do for each, and we know how to do this for each, right? We do system.out dot, well, not dot, println to print them out. So exactly the same output. It's just that this is easier to write now. You can just write it in a single line, although it's a long line, so I'd probably break it apart so that you guys can see it in one go. So this is a filter. Is this clear? So what happens right here, we are printing the person itself. What if I wanted to do something with the input itself? So for example, I want to print the name of the person only. Can we do that? And I'll try to do it in two ways as well. So I want to print the names in uppercase. So I just don't want to print the whole data of the person. I just want to print the names. You can call get name, and then there is a method called to uppercase to turn the name into uppercase. We can do that. So this is how it runs, right? And this is our old code. We could write it like this. With lambda expressions, we can actually not only lambda expressions and also with strings, you can do the same thing. Names in uppercase. It's not going to print names in uppercase for the next entries. It's not going to work. See, because we have to pass the entire object, and when we pass the entire object over here, you see, this one says for each do this thing, and when it prints the entire object. There's nothing left. So then we can use something called a map that takes a person and converts it to something else. From a person we can call person dot get name, and on that get name we can say to uppercase. So that's a map. These are some common methods that we will use from time to time. One is filter. Filter is to filter out specific things against a certain criteria. And then map is to convert it to something else. Map is like a function. It takes an input, turns it to something else, a different output. Filter is like a search function that if the criteria is met, only those things are filtered out. So over here, what we want is that all the people that are greater than 50 years old, we want to change the name into uppercase. That's what we're doing. Is this thing clear? This example? Okay. Let me look at the output first, and then let's see what we can do. So we got quite a few names here, and let us say I want to use two filters. First of all, I want to find out all the names, all the persons that are more than 50 years old. And again, another condition that their name has to end with UL. So there are two people that are more than 50 years old, these two. And often, only one has a name that ends with UL. If I ask you to write this thing in Java, can you write a program like it? Can you write this statement? Yes, you'd have to check both conditions. The way we'd write that, let me copy this over here. So this is the task. I want to print all the persons with enhanced forward. Right now, it doesn't do that. It prints both names, but it should only print this Putul and nothing else. How can we do this? We have to add another condition over here that says person dot get name. There's a method which is very convenient. It says ends with, and you can pass a suffix. It ends with ul, so it filters out that part, and you can write that and see there is only one entry. Can we do the same thing with streams and lambda expressions, just as we have done that before with filter? So let us try this out. This is the basic stuff as we had, which prints two entries with streams and lambda. Now I want to add, I forgot to copy the comment line. Okay, I don't have that comment line anyway. Printing with streams and lambda. So this is where I've applied one filter to filter out all the names, all the persons that are more than 50 years old. And now I'm going to add another filter. I'm going to take person. Which person? So if you compare these two parts, you may feel like, this is being more verbose now, like you have to write a bit more, but this is actually more readable. If someone's reading your code, they can clearly understand that you're working with a collection, and this collection is being treated as a stream. And then you're filtering it out in multiple goes. See, how are we filtering this out? First of all, we're taking all the names, all the persons who are more than 50 years old, and from that subset, we're again using another filter to try this. Whoever's name ends with ul, we're only taking those people, and then we're for each of them, we're going to print them out.
Sir, the data condition true method doesn't.
Yes.
You
You can't write it like that, even lambda expression not like that. That's going to get a little bit tricky. So you'd have to write the filter function with or in that way. This is an obvious and, that's why we can apply the filter twice. But if you want to allow or, then you could write person.get age greater than 50 or something else like that ends with ul. So if any of those two conditions met, just filter those out. So that's one way of writing these things, and these are better to read once you get the hang of it. And if for other people too, the name clearly says that you're filtering these out, so these are easier to understand. And from all those subsets, you can perform these things. And the other thing, like I said before, these things can be done in parallel, which means that they can run a little bit more efficiently than you'd manage with regular enhanced for loops. So if you have a lot of data, and that's an issue these days, that you have to handle a whole lot of data. You're working with huge databases. You need to process them fast. So all those just simple for loops are not good enough anymore. You'd have to find better ways of enhancing your task. Again, I'm actually rewriting a lot of code I wrote before. For example, the exam schedule preparation and class schedule preparation, those codes. I'm rewriting some of those things in terms of Lambda expression and streams API just for performance issues and nothing else. So that's that. Let us look at some other examples. Let's say I want to sort all these people by their age. How can we write that? Let's try both of them. So I want to sort the person list based on age, and the way we have learned how to do it in today's class, right at the beginning, and also in the previous class, we could say something like collections dot sort, right? And this is where we pass the person list and say how do we compare two person with Lambda expression. We could say P1, P2, and then write the Lambda expression right down. So something like if P1's age is less than P2's age, how do we get that? P1.getAge is less than P2.getAge. Return -1. Else if this is greater, otherwise return 0. So now it works, and just to prove that this really works, let us print it out. We know how to print it in a short code. We can just say that persons list dot stream dot for each system dot out dot println, and that's that. So it prints it out properly. It's all sorted by the age. Actually, let me print out a extra line system.println. So with Lambda expression, we can get this sorted by age. Easy stuff. I mean, we have learned how to do it. We are actually writing a comparator right here with Lambda expressions. Okay. Can we do this a little bit better? There's a method right in here. Say sorted. And this is where we can pass a comparator. Comparator has some static methods, and I can use comparison basis. So I can say comparator.comparing, and what am I comparing by? The age, right? How do you get the age of a person? You can say person arrow person dot get age. Okay, so let us test this out if it really works or not. Let me copy this. And let me comment out the whole thing. They should both do exactly the same thing. What? Oh. Works. Yeah, it was a mistake. I mean, I treated it as a separate stream and then I was printing it. So that's why it didn't work. Let's see. This single line does exactly the same thing as all these lines. So it's a lot less coding. Let me bring them out in the whole screen so that you guys can see this. So we are comparing, we are sorting by a certain factor, and then for each of these items we are printing them out. That's the whole code. Okay, you can put it in one line. It's just that it's taking too long. It's going outside the screen width. That's why I don't like it. And you can also make it a little bit shorter, since it's a parameter list method. We don't need to pass any parameter. We can just say person double colon and get age. Yeah. There has to be a reverse method. How do you do that? Let me look it up. I forgot how to do it. Java stream reverse sorted. Comparator and then reversed. That's where you do the reversed. So you could also do it in descending order. And fun thing is, let me take an example right in here. This is the age-wise comparison, right? So let me come up with a different set of data. Say we have multiple outputs, right? For some reason we have that, and they are of different age. So one is 42 years old, the other one is 24 years old, and let's say the last one is 14 years old. They have different IDs as well. So that's what it is. Let's say I want to sort them by their names first. And once they're sorted by their name, I want to sort them by their ID first. So all these apples, they should be put together right at the beginning, right? Because their names, they start with A. So apple 1, apple 2, apple 3, something like that. But then inside that, I want the apple that's the youngest one, it's 14 years old, has to appear right at the beginning. If I give you guys this task, would you be able to do that? Not with the new stuff, with whatever we have covered before Kidix starts. No? Yeah, well, let us try this out. I mean, let us try to write it in a long fashion, and then we'll see how we can do it better. So, first of all, what we could do is we could write collections dot sort, and then pass the person list, and then we can pass P1, P2, two person, and we'd write a lambda expression in here. That's the idea, right? How do you compare two person? By their name first. See, what are the things that can happen? When we are comparing two persons, either their name are the same or the names are different. I'm comparing by name first. If the names are different, only then I'd have to say that, well, if you look at this data, comparing John with Jane, their names are different. So which one should come first? Now in between these two, Jane should come first because this is JA compared with JO, and JA should come first, which is easy. If you compare with Jane and Abu, that's also obvious. Abu has to come first, Jane has to go later on. However, when you compare two Abus that have the same names, then only you have to go for a different category, which is going to be their age now, right? So how am I supposed to write this then? I have to think about this problem in two different categories. One is the names can be different, the other is the name can be the same. Is this clear? When the names are the same, then only I look at the age. 42 compared with 24, or 24 compared with 14, or 42 compared with 14. These are the two different things that can come up. So down here, first of all, I look at the names. So if person 1 dot get name dot compare to person 2 dot get name equal 0, if these two persons they have the same name, which one should be smaller? Depending on the age, right? If person 1 dot get age is less than person 2 dot get age, then which one's smaller? Person 1 is smaller. And how do we indicate that? Well, yeah, there can be another category over there. Then we'd write that if the age is equal, then go for the third one. Perhaps the ID number, then we will match that. Yes, there can be many different levels of keys. So now what we can write here, return a negative number, such as -1, else if P1's age is greater than P2's age, we can +1. Otherwise return 0. So that's one case. When the names are equal, then only we go for that. Otherwise, we can simply compare by the name. When the names are not equal, then there is a clear distinction, and that's what we go for. So we can write P1 dot get name dot compare to P2 dot get name, because it itself is going to return an integer which will tell us which name is smaller. So in this example, when we have John and Jane, these names are not equal. We just say John Doe dot compared to Jane Doe, which returns us some value. It could be a negative number or it could be a positive number, certainly not equal. But it's not going to be equal to 0. So this is where we have sorted out all these person lists. And now if we want to print them out, before printing them out, at least we print this so that we can track. Sort it out by name and then age using lambda expressions. How do you sort that? well, how do you print that? You just say person list dot stream dot for each system out println. Okay. We are relearning a lot of things. It's for our own benefit. So we have 15, 25, 43, which is okay because we are increased the age, right? We have called increase age for all these things. So we don't see 42, 24, all these ages are increased by 1. But what you do see is that we have sorted by the name first, and then by the age. Is this clear? Okay, let me change the data a little bit so that we may have some fun stuff over here as well. Let us have some people with the same age. Alright, so Abul and Ratul, they're both 22 years old. And Abul and John Doe, this one, they're all both 14 years old. I'll need that in a later example. So this is not much of a change. We can still see that the names are sorted by the persons are sorted by the names first and then by their age. Okay. What if I want to write it in a concise form, in a lot less cluttered form? So this is a whole lot of coding. Instead of writing this in this format, can we do this in an easier way? And that's where we can say person list dot stream dot sorted, and inside sorted, what do we pass? Put this one first. We have done one such thing over here. We have to pass comparator and then dot comparing, and then we do something else. Okay, so let's do it one at a time. So we turn this into a string. We say that this string needs to be sorted, and sorted by what? Comparator dot comparing. Comparing what? The name. How do you say the name? Person get name, as simple as that. Okay, so if it's just the name you're comparing, right, it's no big deal. You just say for each system out println. Okay, so this is not the correct answer, but I mean it will get you somewhere. It will sort everything by the name, right? Just the name and nothing else. So if you run this, then we see this thing. These are all sorted by the name, but they may or may not be sorted by the age. For now, it's sorted by the age as well, but I mean, it's not guaranteed that that's going to happen. Actually, this method is called already, so let me comment this out for now. I don't want this here. So yeah, sometimes it's going to get the age sorted already, but I mean, this is not guaranteed because I'm only comparing by the name and nothing else. So I want to extend this. I want to use something else. I want to sort by name, but at the same time, after sorting by the name, I want to do something else. See, this is fun. It just says then comparing. Then comparing what do I need to compare by? What's wrong with me? All right. So this is a lot simpler. If I have more keys that I want to compare with, as Rahul was suggesting, like if the name are the same, if the age is the same, then what if I have to get another key, for example the ID? You just say then comparing person get ID. So right now, if you run this program, it's going to work fine, and you get to see the names sorted and also the age sorted. What if I change my requirement now? What if I tell you I want to sort all these people's record by the age first and then by the name? Then it's really easy to write this over here. Right? You just need to switch these two lines. You put this line over here, not then comparing. You just say this is comparing, and say then comparing that. And if you run this program, you'd see that all the people that are 15 years old are grouped together first, and in that they're sorted within their name. Like Abul comes first. The people who are 23 years old, they're also sorted after that. First comes Abul, then comes sorted. So this is really easy. However, if you look at this method, in this implementation that's commented out, if I change the requirement, I tell you that you need to sort them by their age first and then by their name. It's a small change in requirement. This method simply needs to be rewritten in a totally different way. Because first of all, you don't get to say that two names, two ages are the same. You can't do that comparison. You have to write it in a totally different way. If P1.getAge is equal to P2.getAge, then do the name-based comparison. Else, you write that. So in your total code, what's here, you have to rewrite the whole thing. There's a big change in here. However, if you use strings API, this gets a lot more manageable because these are written in a different pattern. You're building these up. Like this comparator, you're just saying one after another that these are the things I need to compare by. Is this clear? So right now we are printing this out and that's it. And that's the task. Okay. Sometimes though, like printing it is not the end of the world. Like you'd want to do something else with that. You'd want to filter out and get a subset of items. Sometimes you want to find out the minimum element. Sometimes you want to find out the maximum element. Sometimes you want to run through all these elements to sum up some particular item. Okay. For example, if I wanted to find out the person with the minimum age, how can I do that? And you could say that I need to sort the whole thing and then I get the first entry from there. It's going to be a bad answer because then sorting is a more expensive operation compared to searching for the minimum entry. For most of you, this is probably not known at this point because you haven't done the algorithm course yet. But when you get there, you understand that to sort a list of items that has n number of entries, it takes a time complexity of n log n. So n is the number of elements, you have to multiply that by log n, which is more than 1. So then the whole thing is slightly more than compared to searching for a certain thing inside that list that takes at most order of n time, because you just need to look at each and every entry. You don't have to compare one entry against another one. So searching is actually faster than sorting. So if you want to answer the query of a search by sorting it first, it's not going to be a good strategy. There has to be better ways to do that thing. I'm running out of time, that's why I'm not going to finish this right now. But in our next class, which is going to be Monday next week, I will show you how to get this thing done, how to perform those aggregation operations, how to find out the summation of some certain thing. For example, summation of all these ages. You can do that, or find out the min or the max, or to get the sublist from a list using strings. We already know how to do this. Excuse me. We know how to do this with enhanced for loop and writing our own if-else statements. We can do that. That's no big deal. Everyone should be able to do that at this point. However, this is new stuff. It can offer a lot of advantages if you write it in a proper way. In terms of efficiency, that's one thing. And also in terms of code maintainability and readability. these things are more readable, so that if you learn how to do these things, people who are working with your code, or you yourself down the line, 6 months from now, can look at the code and readily understand what's been written. Because they are quite specific. I want it sorted, I want to use comparator. What's the comparison? Age and name compared to this. If you look at this, well, this is much more complex. I mean, some people would ask, like, why you return -1 and +1? Why are you comparing the name first like that? But if you look at this code, this is much more readable. It clearly gives you the message right away. Okay, and that's a very important aspect when you write your code. You have to write it in a way that people would understand without explaining that to them. Any questions on these topics? One thing though, like these are new stuff that's brought into the language, like Java 8. I'm not going to say it's new because Java 9 is supposed to come out within a few days. We'll have Java 9, and that brings in some new features as well. We'll have modularity. But now is not a point to talk about Java 9 because it's not released yet. For Java 8, since it's pretty new, our textbooks that we picked up doesn't really cover Java 8 stuff. What I can do though, like I can give you some tutorials, I can give you some links to our classroom that you can go through those to learn about these new features. Those are not covered in any of the 2 textbooks that we have picked. Not in Java How to Program, not in Head First Java. Okay, so I'll just give you some tutorials to look into those things. There's also a textbook, well, not a textbook, a book on Java 8 features, Java 8 for the really impatient. You can download that and read from there. That's the name. Java 8 for the really impatient. That's the name of the book. You can look it up. You can find PDF of that as well. And there's actually, you don't have to get the book. There are some tutorials. I will post some links. But if you find that it's easier read from a book, I'd refer that. Okay. You can finish the